Challenge number 3 was called Magic 8-Ball. Looking at the files provided, we have a bit more of them, but they are external SDL2 library files and resources assets, image of a ball, fonts, and some text files with licenses. Let's see what future this Magic 8-Ball can predict for us. Again, run it in VM if you are not sure about the effects on your system. We can see the image of a ball on the screen. This is the same one that we could see in the assets. As suggested on the screen, we can press arrow keys to shake the ball, we can type our question and get a reply from the ball. A few more tries to see if something unexpected can happen. Let's tear this binary apart. Loading it to Ghidra. Nothing fancy here, just use the default settings as usual. If we go from entry function down into sub-functions, the amount of code will grow quickly. So this time, we will start from the bottom and work our way up. Let's start by filtering a string press arrow keys to shake the ball that we saw when we ran the challenge. From there, we can press the xref and navigate to the place in the binary where it is being referenced. This function looks rather complex, but we can try to make it a bit easier to understand. First of all, see those hex numbers? With some experience, we can recognize that those are values in printable ASCII range. Let's tell Ghidra to treat them like that. We can see the string in the disassembly and it reads "gimme flag please." Unfortunately, we can't see that string in the decompile view. Second thing that we can do is to try to add some type information to all those parts that reference this plus an offset. This seems to be a C++ class that Ghidra can automatically try to regenerate for us. Just click on this and press Auto-Generate Class Structure, and all those addresses plus offset operation will be converted to a field access. Nice. We can name some of the fields based on the operation that's being performed with them. Like here, we load some asset file and convert it to a texture. So it looks like field 570 holds a texture of our Magic 8-Ball. Let's call it like that. Here, field 571 holds a Noto Sans regular font. Let's name it then. We can continue with some other fields, while some might not be that clear just yet. We don't know if it might be helpful with finding the flag, but for sure we'll make it more clear if we encounter those fields later in the program. From all the code that we see, seems like this is some kind of prepare scene function. Let's rename it that way and move up to the place where it's being called from. Okay, here it looks like a game loop. We get the tick count, then we prepare scene, our just renamed function. What we are missing from a typical game loop is the response to the user input and drawing the screen. Those could be the two functions not yet analyzed by us. And at the end, we wait so that the game does run with a predictable speed. Before we go into the first of the unknown function, let's set the name of object located at 406090. That's our Magic 8-Ball context. Now we can go to the first of yet unknown function, 4024EO, keeping in mind that it takes that context as a parameter. Yet, inside the function, the signature is that it takes void pointer. Let's fix that. By applying the type, we got rid of those nasty pointers plus offset expression, and instead we see our fields. Scrolling through this function, it's not obviously clear what it does, but we can see an interesting check near the end of it. It might be something else, but the usage of strings L like left, U like up, R for right, D for down, might indicate that this is the sequence of ball shakes that we need to perform. Before we try that in the game, let's try to analyze the code. The sequence is being compared with a variables named PCVAR4 and PCVAR5, and those are being set based on a variable named this. Not so good name. Let's rename that to maybe input. If we click on it, Ghidra will highlight the places and we can scroll up to see that it's being passed to a function 401780 with some extra parameters. If we check the dot parameters, we will see that those hold strings L, U, R and D, but due to short characters number, Ghidra did not convert those to strings, as by default only strings longer than 3 characters are recognized as such. We can convert them manually. Right click on the name, pick data and from there string. For next occurrences, we can just use Y on the keyboard as it will apply latest pick. Now it's more clear what's happening. If we take part of the code that is near the string for down, we can see this part is executed if field 333 is set to a non-zero value. If we check all the references, we see an interesting set this value to 1 if the variable name local2c is set to this specific value. This code looks like it's handling different events, so this might be a field that indicates that the down arrow is pressed. Let's name it that. Going back, we can deduce the same for field 334 to be a variable for left arrow, field 335 for the right arrow, and apparently field magical ball should be an up arrow. It really does look like this is what we need to do to get the flag. Let's find out. Typing the magic phrase "gimme flag please" and shaking it. Left, left, up, right, up, left, down, up, left. It's not Konami code, but it gives us the flag. See you in the challenge number 4.